Hello YouTubers, this is Carl. I'm kind of a car guy and I'm going to document a build I'm working on, and I'm just going to show you guys along the way, I guess. Let me give you a little backstory here. Let me see if I can change my cameras around. Alright guys, this is my SN95. It's a little, it's actually a 97 Mustang GT. And this body style is actually from 94 through 98. It was just after the Fox bodies. I got a tubular K member down in there. I don't know if you can see that, but then I got the engine pulled out. I got it put over here on the stand. I'm actually rebuilding it. It actually came with a GT engine. About 3 years ago I put this Cobra engine in it, and now I have pulled it again so that I can beef up the internals, because I'm going to add boost to it. So this is kind of my engine tore down, and yeah, I got a bunch of stuff for it. I'm going to be putting in it. It's actually playing with these cams right now, kind of looking at how they're in here. These are actually Sean Highland Motorsports regrinds, and some people hate those, some people love them. I don't know. I don't think they're that difficult to set up, to be honest, but some people are afraid of them. So these are these cams are a 235 duration. I think it's 474 lift. They're great for boosted applications anyway. Sure, you can use them naturally aspirated as well, but you know, I think to get the most out of them, you're supposed to run them with boost. So, which is okay because I'm using boost. These heads have been ported. I ported and polished them last time I had this engine apart. There was a lot of work. Got like 32 valves worth, so it's a lot of porting and polishing. Let me grab my light so you can get a better view. I'll show you. Alright, so yeah, I got all the valves out of it. I got everything pulled out of it. I don't know if you can see that real good, but I got all these ported, polished up. Even on the exhaust side too. Exhaust side is ported and polished. I don't know if you can see real good. I got some new valve guides in there because the other ones started to wear out. So especially with radical cams, I want to make sure they're good and set up. Alright, sorry about that guys, I had to take care of a customer. But anyway, so just a backstory. Yeah, I got a 97 Mustang GT. Had, I don't know, 5, 6, 7 years, several years. And I took the original GT engine out of it. It was a 4.6. It was a 2-valve motor. It's still overhead cam, but it's a 2-valve engine. 2 valves per cylinder. So I got to modifying it. I put intake and exhaust on it, and then naturally you want more power. So I found a Mark 8 engine, which is basically a Cobra motor. It's very similar to a Cobra motor. It's a dual overhead cam, 32 valve engine. So it's still 4.6 liters, but it's 32 valve. We'll just call it a heavy breather. It breathes a lot better than a standard 2 valve engine, and it can make a lot more power. So I think the factory GT is like a 265 horse or somewhere around there. 260. Actually, on this one is a little older. I think it's more like 230 maybe. I don't know. Because it was a non-PI. They had some head changes over the years. But the 2-valve engine eventually went to about 265 horse engine, and the Cobras came out factory. Especially these are B heads, or B cylinder heads, and these heads these outflow everything. These really overflow actually. And it pumps out factory. I think on these engines was around 300, 305, somewhere in that range. And so So yeah, I got this engine on a deal, and I pulled it apart, and I cleaned it up and ported it and polished 32 valves worth, and then I just stuck it in there as an all-motor engine. I ran it for 2 or 3 years like that. It made pretty good horsepower, did some tunes on it. Then now I'm in the process of potentially boosting it, so I want to make even more. I want to get 5, 6, 700 horse. I want to be able to push it a little further. So which these engines are well capable of doing it. So but yeah, I was just kind of take you along the journey, and sorry about that, and and show you this build anyway. So I'm building the engine. I got forged pistons, forged rods. I got a bunch of goodies for it. So yeah, I got some. These are forged rods, king bearings, and these are forged pistons. These are like a stock, as many of you know, a stock 4.6 liter Cobra. I think the 03, 04 models came factory with these forged pistons, and these are kind of a reproduction. They're a make of the factory Ford piston, only they're oversized, like half mil oversized, or in other words 20 thousandths. And so I had the engine block bored 20 thousandths over. I put forged rods. Some people like the H-beam rods. I like the I-beam rods. Everybody's got differences and preferences, but either way, either one type of rod can make a lot of power. These rods nowadays, as long as you get forged pistons, forged rods, you can push a lot of boost and make 1,000 horsepower plus with them pretty easily. So there's some headers, cheap headers. I had to beat the crap out of them to make them fit. I may end up re-welding them, changing them a little bit. Got all the valves pulled out of it. As you can see, all the valves out of here are out. Some of them I'm gonna have to replace. Some of them can be cleaned up. Got the valve springs over here. Anyway, got the main bearing caps over here. As you can see, these are like 4-bolt. If you consider the jack screw on the side, it's more like a 6-bolt. So, and of course the ARP studs. You got all these heavy-duty ARP studs. These are head studs and the main studs. Anyway, just kind of trying to bulletproof the block and make it extra beefy. But I mocked up these cams in here, and I don't know if you can see in there, but I got just kind of a dinky little spring in here, just holding the valve in place and holding the rocker arm against it, just to see what the valve geometry is going to be like. It looks like it's going to be pretty good, to be honest. So yeah, I got the heads just bolted on with 2 bolts, and I was going to show you guys kind of a cool view of the inner parts of the engine. Give me a second here. Let me rotate this thing around. Trying to do this one hand is kind of difficult. So, all right. So let me show you. These are the main studs. Of course, these are all ARP heavy duty stuff, heavy duty ARP main studs, not the factory stuff. Here's what the cylinder looks like with no valves and the head on. You can kind of see what it looks, kind of a neat view with no piston, no valves. Kind of see what it looks like in there. And here's what it looks like with just 2 valves installed. Let me grab my light, see if we can get even some better light on it. Alright, so I don't know how well you can see this. We're going to try and make the most of it. Alright, we're back again. Let me see how well we can see this. So here's the valves in there, and I'm going to give you a demonstration of how they move up and down in the cylinders. So This would be intake, and this would be exhaust. So, and then, so it's like 474 lift, and the duration is like 235 on intake and exhaust. And then I think it's on 114 lobe separation angle. And you know how a lot of people talk about lobe separation angles. That's the point at which both valves are open simultaneously, just for a slight brief moment. I don't know if I can demonstrate that here, because it pretty much almost closes. There you go. There would be your lobe separation angle. Alright. So you see how both of them are slightly open simultaneously? That's like 114. Now if you change that, if you were to go over here and change these a little bit, these cams, or these sprockets. Of course, I'm not going to do this, but I'm just doing this for demonstration. If we take here, we take and it's supposed to line up these little dots, all right, with the markers, the chain marks, and that's how you get it in alignment. But I'm actually gonna put it one notch over just to show you a different lobe separation angle. See if I can do this. There. There we go. Alright. See what that does right there. This should give me a tighter lobe separation angle. Alright, intake, combustion, compression, combustion, and then exhaust, and then intake. Now this is a wider separation angle. Let me go the other way with it. Alright. Give me just a second. Alrighty. So now, alright, what do we got here? Alright, we're going backwards. Alright. So intake and exhaust. Actually, they're still pretty close. Alright, here we are again. I got these adjusted a little bit tighter, so the lobe separation angle is going to be a little closer to probably, I don't know, 109, 110. I don't have my degree wheel on there, so I don't know exactly, but so if that's your exhaust, when it begins to close, you'll see the intake just start to open. Oh, here. Doing this kind of backwards here. So exhaust closing and intake opening kind of right at the same time. So that would be like a real tight lobe separation angle. That's like 110 or 109 or 110 or something. Probably something close to that. And that's where you get a lot of scavenging. You get a lot of air that just actually bleeds straight from the intake through the exhaust port. And that's where you get that that real loppy idle. Alright guys, here's another quick demonstration of what I was talking about for lobe separation angle and valve lift. I don't know if you can see this, but this would be that overlap I was talking about, where you got both valves simultaneously open. So that would be on a real tight, like 110 or 109 lobe separation angle. Of course, I'm not running that, but it's just that's what gives you that real loppy blah 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 blah, you know. Anyway, but yeah, I kind of like these cams. They actually have, for what they are, they actually have a really pretty good lift. I mean, that's almost a ½ inch of lift, so that's pretty awesome. So this thing is, I mean, you don't even need that much, being as though it's a 4-valve engine. But these are like 474 lift. It's almost a ½ inch of lift on intake and exhaust. So you know it's gonna breathe really good. Okay, so for example, this is some of the different camshafts they put in some of the factory stuff, without all the different factory cams. So the 0304 Cobra cams, which is what I have, also the Mach 1, the Aviator, Navigator, GT, a lot of them have 190 degrees of duration and 394 lift, 397 on the exhaust. That's like factory stuff. And you can see some of the other Cobras and some of the other ones have different. The closest to what I got is right here. This FR500 has 212, 208 of duration at 472 lift. So those are pretty awesome cams for the FR500s. Those would be the closest to what I would call these Sean Highland cams, because these are 235 at 474. So 474 lift, 235 degrees of duration, or is what it's supposed to have. We'll see what it actually comes out as when I degree the cams. But yeah, you can kind of see all the different ones. See, I got Mark 8 cams, and then in here, down in here, I got Mark 8 cams. But I also have the 0304 Cobra cams, which is what I put in there when I first run the car. Had the 0304 cams, and they're a little bit more duration, I have to say, than the Mark 8s. I think the lift is about the same, but I think the duration is just a little more. So yeah, that's kind of where you would get the real loppy idles, you know, the real choppy, you know, when people say they got cams, you know, and they're kind of radical, then they get that overlap of both intake and exhaust valve simultaneously open, just a touch. I mean, just a couple thousandths, not even a whole lot, but just a little bit. But for boosted applications, that's not real great, because you're blowing your boost right out your exhaust, and that's not what you want to do. So you actually want a wider separation angle when it comes to cams. You want like 114 lobe separation angle, or 112 to 114. That 108, 109, you know, that's kind of for the old small block Chevy stuff, or like an old pushrod engine Ford 289 or 302, you know. And you can get a real choppy, you know, it likes to rev up like that, you know. But for a boosted application, you want to stick closer to a wider separation angle of intake and exhaust lobes of like 112 to 114. Some are even up to 116, I think, you know. Anyway, I just thought I would show you a little demonstration of the cams being in there and the valves opening and closing simultaneously. There's kind of a inside look of all the cylinders with no valves. It's kind of cool looking. Yep. Here's the other head. I got the other head on there too. Not that I have to, but so anyway. But yeah, I got the ARP main studs. I got the side jack screws. It's actually got a screw that goes in the side of the block, or in the side of the mains, to stabilize it. And that's kind of a neat feature on these blocks. It actually makes them very stout and very sturdy. That way you can really push a lot of boost to them. I've seen this block right here easily be pushed over 1,000 horsepower. You know, like 1,500. I think MMR actually made close to 2,000 horsepower with this engine. I don't know the extreme of what they did for mods on it to get it there, but I know the block is well capable. Alright, so I got the heads pulled back off of it just to kind of show you. I had this, I don't know if you can see real well, but I've had this the surface redecked. So it's all, they redecked the block. They could put a new surface to this surface area here, which is your deck height. And then I also had it bored over about 20 thousandths. Not a whole lot, but just enough for those new pistons to go in there. Or some people call them jugs. They're jugs, you know. These are the bores. So yeah, that's the block after the machine shop, after they did their thing with it. Redecked the block, cleaned it. You know, originally this was all pretty nice blue. They did their cleaning and a lot of the paint came off. So anyway, but yeah, this is the new surfacings, and getting ready for the build. So I'll let you know what happens. This here is the crankshaft. It's still mostly stock. I kind of polished up some of the natural casting in it. It is a cast crank. So and I've seen these push pretty high too. I've never seen one actually break, but they say they can handle quite a lot of power. So I'm gonna push this one as far as it'll go anyway, and then see what we get. Some people say you have to run forged. I don't think you have to run forged, because there's many times they run these cranks and I've never even seen a cast one break. You have to really push it up there over 1,000 horse, I think. But yeah, I polished it up, kind of knife edged it a little bit, sharpened the edges for windage a little bit. And that helps, you know, keep the windage down. Also, when you polish it and get some of the casting off, it helps to shed oil faster. And so it keeps more of the oil in the pan, so you don't lose oil pressure. Kind of keep that keep oil under control anyway. These are some of the bearings. This is the rod bearings, main bearings. I got some Brian Tooley valve springs put in it. I got cams. These are the old valve springs and the valves. Thinking about upgrading valves, but I'll see what happens. And like I said, I got a bunch of ARP stuff. These are the side jack screws. These are the main studs that hold the heads on, or the head studs. Main studs are on the block, and here's the bolts, the kind of bolts that hold them. So main studs make it a lot stronger and beefier. Alright guys, so here is a factory piston, kind of a flat top. It's got a real slight dish to it, but not much. Factory rings, factory piston, and a factory rod. Now these are good up to about 450. I wouldn't say horsepower. You could push 500 horsepower, but I would say 450 torque. When you're putting more than 450 torque to the rear wheels, the rod is the weak link. It'll actually shatter through here. And then of course the cast pistons, they're capable of quite a bit, but they'll break over time too. So if we want to push big horsepower, we have to get forged stuff. This rod, as you can see, is a lot beefier. If you look through the I-beam part of it, it's a lot heavier duty. It's actually almost the same weight as factory rod, which is good, but it's a lot heavier duty. This is a forged rod. This is a it's almost like a cast rod, but it's actually what they call metallurgy. They actually it's pressed metal. It's actually, you just look up metallurgy and you can see how they make these factories. It's kind of interesting. And this is a cast piece as well. You can see all the casting marks inside there. That right there shows you it's a cast piston. You can see all these casting marks, and so that's basically a cast piston. And this is a forged piston. And you can see in here they actually press it and forge it. Don't mind my two little drill marks. That's for balancing. I had to lighten it up just a tad. But you can see there's no markings in here, which indicates it is and even on the side, sometimes you see it right here or right here, some casting marks. And these are forged. These are all forged pistons. So super heavy duty. Male rings. The rings are made by Male, and I've already gapped them. I've already measured. I've already filed the rings and made the gaps right. But yeah, that's just kind of the difference between factory cast stuff and forged stuff. When you go forged like this, you can push a whole lot more power. Alright, bye. So anyway, yeah, that's my 4.6 liter modular engine. It's the dual overhead cam 32 valve. So a Cobra motor basically. And I'm gonna boost it, make some more horsepower with it. This car is I think I forgot to mention, this car also is a 5-speed. It's got the T45 in it. It's kind of very similar to a this is the T45 that's pulled out. I got it pulled apart a little bit. It's actually a lot of the internals, a lot of it's the same based on the old T5s, but it's a little bit more beefy, can handle a little more torque. To be honest, I was fixing the reverse problems that these typically have. These two gears right here are the reverse gears. It's actually 3 gears. There's one in the case, in the back of the case here. See there, and that makes it a reverse gear. But these, they have a problem because they run a dual fork. They run this fork over here that actually has 2 shift forks, one that's supposed to go on this and one that goes on this synchronizer. This synchronizer over here though, what I did is I took it off, I flipped it around because it actually rides on that little groove right there. I cut off the fork and took the pads off of it, and you weld it there to where this gear moves all the time. Otherwise this gear would shift in and out with reverse, and they tend to lock up and bind right here because both forks are trying to push up and down simultaneously, and they jam a lot. So if you flip it around, weld it to it, and then set it on there and put your C-clips on there, this will move all the time, and this will actually drive the smaller gear inside of here all the time too, but this one here will spin freely. Even though the gear is turning, this one will not be engaged until you put it in reverse. When you put it in reverse, when you shift it into reverse, this comes up and it'll engage into that, and then you'll have reverse gear. Otherwise this will just spin freely, forward or reverse, whatever you're doing. But the synchro also engages 5th gear, so it's 5th and reverse. So if it goes down, it shifts into 5th. If it goes up, it grabs reverse. But this is actually a hack. It's kind of a fix for the reverse because they tend to bind up and jam, and I was having trouble with the reverse popping out and giving issues, so I decided to fix that while I had the motor part. Anyway, so that's kind of what I'm working on in a nutshell. Hit it, if, like, subscribe, ring the bell, you know, let me know what you guys think about this build, and we'll kind of go from there. I'll update you along the way. But yeah, I've run this motor for a couple years with about 350 horse, and now I'm gonna boost it and see what we can get out of it. So, alright, thanks, bye.